On today's episode, seals and boots matter, but do we care? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. In almost all mechanical design, particularly in automotive, moving parts need to be lubricated. Now, everyone understands the importance of lubrication, and billions of dollars are spent formulating, developing, and testing oils and greases to fight wear, corrosion, and seizure. Now, if you want to lubricate a control rod mechanism in a nuclear reactor, or bearings in the hot section of a turbojet engine, or an actuator on a satellite in geosynchronous orbit, there's a lubricant formulated just for you. But in the more pedestrian world where most of us live, we just want our machines to work and to have a reasonable service life. Which brings me to this. This is a lower ball joint for my current ride, a 2003 Ford Ranger pickup. Yes, it's old and I drive it for a reason, primarily because, believe it or not, when I'm not talking about engineering here, I relax by wrenching old machinery like that pickup. It also gives me the ability to see where the weak spots are and where automotive engineers have used clever design to get around problems. This ball joint failed, and the reason is pretty obvious. The boot is torn, allowing water and dirt in and grease out. The resulting grease, water, and grit paste simply ground the ball down to the point where steering issues and premature tire wear reared its head. Now, this is very common, but the interesting thing is chassis component technology in the aftermarket, like the ball joint I installed to replace this one, focuses on metallurgy. The steels that go into the joint, the surface finish of the machining, even the strength of the fasteners. But what really determines the service life of this part, and many like it, is the durability of the seal. Now, you can't lubricate these automotive chassis parts anymore, so the factory grease is all there is, which brings us back to the boot. Now, these are made of either rubber or injection molded elastomers, and they lead a tough life under the chassis. The same with these small boots. These came from the same Ford's brake caliper pins, and failure here led to brake caliper seizure and all the expensive downstream effects that results. Yet I've never seen a brake service kit or remanufactured caliper whose primary selling point is high durability elastomers. Now, warranting this ball joint for life is meaningless to me. These are an incredible pain in the butt to replace. Handing me a new one over the counter when the old one wears out is not my idea of a lifetime warranty. What I would like is enough of that aerospace technology applied to boots and seals in components like ball joints, tie rod ends, and caliper pin boots to make them grease tight for the service life of the part. Now, would I pay $5 more for a part with a high technology, highly durable boot or seal? Yes. Would I tolerate weaker metallurgy and a less precise surface finish on machine parts in exchange for that tough boot? Yes again. Now, we know that this isn't a case of planned obsolescence, as I come from the industry, and that's been widely overplayed. It's possible these parts do last the expected lifetime of a modern vehicle, but people are keeping cars much longer now. The average age of an American automobile is now 12.1 years. Many are much older. Many of you, like me, operate vehicles in tough conditions. Off-road, dirt roads, stones, potholes, snow, ice, dust. Almost any form of North American driving can be considered severe service, which is reflected in vehicle service intervals. The irony is automotive engines rarely leak oil today because of superior sealing technology. Yet that oil is changed regularly. But the grease in this ball joint can't be changed or even topped up. Yet the boot failed. Now we know that engineers in the industry can design tougher, more durable seals and bellows. Maybe the marketing people won't let them. But how about it, folks? Can I at least have the option of those space-age sealing materials? Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.